All right, so chapter 4 is all about quadratic functions. But for our introductory example here, Lois is practicing vertical takeoffs and vertical landings with her new drone. So vertical means going straight up and straight down. So she wants to take off vertically, going straight up, and then land the drone straight down, okay? The table below shows a record of the drone's height in feet above the ground as a function of time in seconds. So according to the table, at 0 seconds, when she first starts, the height of the drone is 0 feet. That should make perfect sense, right? We haven't done anything yet. Then after 2 seconds, the drone's height is 64 feet. After 4 seconds, 118 feet. 6 seconds, 150 feet. 8 seconds, 161 feet. So the height is increasing until it gets to a height of 161. And then notice it starts decreasing again. Goes back down to 151, 118, 64, and 0. All right, for the first problem, we're asked to plot these points. Let's add some color to our lives. We'll make it red. All right, so we'll plot the points from the table. 0, 0, 264. That's about here. 4, 118. That would be about here. 6, 150. That's here. 8, 161. And then 10, 150. What's next? 12, 118. 14, 64. And 16, 0. So this graph that we get, it doesn't show us the path that the actual drone is going. The drone is going straight up 161 feet, and then it comes straight back down. But when we plot the height over time, we get this shape. When we connect the dots, let me calm my shaky hand and do a better job at connecting my dots. There we go. Boom. This is the graph we get. Okay. Although we're not given a function here, this situation can be modeled with a quadratic function, which we're going to talk about. The graph of a quadratic function is something like what we see here, kind of like, well, it can be a U-shaped or an upside down U-shape. This is called a parabola. And then for part 3 of this problem, we're asked to give a description of what we see from this graph in a parabola. All right, so we have the parabola graph. Part 2 here says, how does the graph shape differ from the path of the drone? So the path that the drone is actually taking is a vertical, it's going vertically upward and then right back down. So it goes up 164 or 161 feet, and then it comes right back down. So the path is a straight line up and down. That is obviously different than the graph that we get. The graph that we're getting, which is the height over time, is a parabola. It does not match up with the path of the drone. There are other situations, though, where we can model the path of an object with the quadratic function. Say, for instance, if you, I don't know, kick a soccer ball, if it goes in the air, if you kick it up and it comes back down, that can be modeled with the quadratic function. Or if you hit a baseball, if you pop it up and it goes up and comes back down, or a golf ball, or if you throw a football and it goes up and comes back down, anything where you have something going up, coming back down, and it kind of has this general shape, we can probably model that with a quadratic function. And it will, well, we can model the path with the quadratic function. But in this case, we're not modeling the path exactly. Okay, part 3. Now, there are some terms in part 3 that we haven't quite defined yet, but the questions that are asked in part 3 are going to be our focus for today's class. What characteristics can be observed from the graph? Discuss the graph's shape. It has a name, a parabola. The opening direction, the vertex, and the axis of symmetry. Okay, so first, the shape that you get when you graph a quadratic function is called a parabola. Let's write that down. And in particular, your parabolas can open either upward or downward. This is an example of a downward opening parabola. So a parabola that opens downward. That just means that the graph is decreasing on both sides. It's going down on both sides. What else are we asked about? Oh, this the shape and opening direction. All right, next, the vertex. So when we have a parabola that opens downward, we end up getting this maximum point at the top. This very topmost point is called the vertex. Okay. In this case, the vertex of the graph is given at the point 8, 161. It's the highest point on the graph. So the vertex here is 8, 161. And this is just telling us after 8 seconds, the drone reaches its maximum height of 161 feet. All right, the other thing we're asked for is the axis of symmetry. All right, as we look at these parabolas, parabolas are symmetric with respect to some particular vertical line. That means there is a vertical line that exists that pretty much divides this parabola in half. And if we reflect the graph over that vertical line, we get the same exact picture. That line is called the axis of symmetry. And if we draw a vertical line, I'm going to draw it in a different color, I'm sorry. If we draw a vertical line that goes directly through the vertex, this vertical line will give us our axis of symmetry. It splits the graph in half so that you have mirror images on both sides. And if you were to flip the graph over that line, you would get the same exact picture. Okay, that vertical line would be x equals 8. And remember, the vertex up here was 8, 161. So it's whatever the x coordinate of the vertex is, x equals 8. That is our axis of symmetry. The axis of symmetry is a line, so you have to, a vertical line, so you have to write it as x equals some number. Okay, and in this case, it's the number 8. Now, we were able to find all of this information just by being given a table of points. In practice, though, we're going to be given a function. We want to be able to identify just by looking at the function whether or not it's quadratic. So we'll talk about what the standard form of a quadratic function looks like. And then we want to determine how we can take the function without the graph and find all of this information. So just by looking at the function, we want to be able to tell if we have a parabola that opens upward or downward. We want to be able to find the vertex, and we want to be able to find the axis of symmetry. Part 4, state the practical domain and practical range of the height function using inequality notation. We need more colors. So in this case, of course, the domain is given by the input values. Our inputs go from 0 to 16. We can see that in the table. We can also see that on the graph. The x's are going from 0 to 16. So for the domain, the possible times are x's between 0 and 16, including 0 and 16. For the range, that will be the heights that we're getting. Okay, those heights start and end at 0, but somewhere in the middle, it goes all the way up to 161. So the lowest possible height is 0. The highest possible height is 161. We can see that on this graph also. If we look at the y's, this gives us the range. It's going from 0 to 161. So for the range, if we write that in using inequality notation, we'll have 0 is less than or equal to y, which is less than or equal to 161. A quadratic function is of the form f of x equals ax squared plus bx plus c. I can highlight that here. Oops. ax squared plus bx plus c, where a, b, and c are real numbers. And well, a can't be equal to 0, but a, b, or b and c can be equal to anything. A can be any real number except 0. So basically, we call it a polynomial, where the highest power of x is 2. So x squared is the highest power. Okay. Quadratic functions have 3 parts, 3 terms. There's the x squared term. In order to be quadratic, we have to have that ax squared term. A is the coefficient of the x squared term. We need to be able to identify those coefficients, a, b, and c. The second term is bx, that's the linear term, and b is the coefficient there. Again, we need to be able to identify that. And the last term is c, which is just a constant term. It'll just be a number. That constant term is its own coefficient, okay? Note, if any term is missing, the coefficient of that term is 0. And note that a cannot be equal to 0. So b and c can be 0, but a cannot be equal to 0. So some examples of what quadratic functions might look like. Something like f of x equals 2x squared plus 5x plus 3. That's a quadratic function. Or g of x equals, we can just have the 2x squared plus 5x. Maybe we don't have a constant. That's still a quadratic function. Or maybe we have just let's call it h now. The 2x squared plus the 3. There's no middle term there. There's no 5x. That's okay too. This is still quadratic. Or I'm running out of letters. E, F, G, H, I. I don't like I of x. J of x, we'll call just the 2x squared by itself. So you can have a quadratic function that has 1 term, 2 terms, or 3 terms. And then for all of these, the graphs will have some similar characteristics. The graphs of any quadratic function is going to be a parabola. Sometimes your parabola opens up, sometimes it opens down. That'll depend on the values of a, b, and c, okay? So all through this section, we're going to practice trying to figure out what do the values of a, b, and c tell us about the graph of our quadratic function. That's summarized in this next part. All right, also in this next part, we are given a table here where we have a linear function, f of x equals mx plus b, an exponential function, f of x equals a times b to the x, and a quadratic function, f of x equals ax squared plus bx plus c. And all of these, the letter b represents something different. So we want to pay attention to what these coefficients represent. For the linear functions, what was m, what was b? For exponential, what's a, what's b? And then for quadratic, what's this a, b, and c? Let's start with the ones that we know, linear and exponential. So for a linear function, f of x equals m times x plus b. M represents a positive or negative slope or rate of change. Looks like rate of change. Let's fix it. Okay. For the exponential function, f of x equals a times b to the x, b was our base, and we said that that represents the growth or decay factor. Okay, and then for for a linear function, y equals mx plus b, the b told us the y-intercept. But for an exponential function, a times b to the x, the a told us the y-intercept. All right, so we can use different variables to mean different things. So we use the same coefficients, a, b, and c, but they mean different things for different types of functions. What do they mean in terms of a quadratic function? All right, this is the new stuff. So first, the value of a, that's the coefficient in front of x squared, that tells us whether or not we have a parabola that opens upward or a parabola that opens downward, okay? If a is greater than 0, we have a parabola that opens upward. A picture of what that might look like would be something like this. like the graph of x squared. That's an upward opening parabola. Okay, if a is less than 0, we have a parabola that opens down, and that's something like what we saw earlier. Okay. Being able to determine if our parabola opens upward or downward is very important because this changes whether or not our vertex is a maximum or minimum. For an upward opening parabola, the vertex is a minimum point. So it's the smallest possible point on the graph. Vertex is a minimum. Okay. But when our parabola opens downward, like in our example from earlier, the vertex gives us the maximum point. So it's important to know whether or not your vertex is the highest point or the lowest point on the graph. That'll help you answer certain questions that we're going to look at, and it'll also help you figure out like the range. Sometimes you'll be asked to find the maximum or minimum that we know that occurs at the vertex. So knowing whether or not our parabola opens upward or downward helps us determine whether we have a maximum or a minimum. Again, opening upward, the vertex is a maximum. Oh, sorry. If a is greater than 0, the graph opens upward and the vertex is a minimum. If a is less than 0, the graph opens downward and the vertex is a maximum. All right, so A tells us which way our graph opens. On to B. The value of B tells us whether or not our vertex is on the y-axis, which means that the y-axis would be our axis of symmetry, or if the y-axis is not the axis of symmetry. So does the y-axis split the parabola in half? If B is equal to 0, the y-axis does split the parabola in half. So the axis of symmetry is the y-axis if B equals 0. If B does not equal 0, then the y-axis is not the axis of symmetry. So just really pictorially, I want to show you guys what we mean by that. I'm going to go to Desmos really quickly. Where is it? And show you two quadratic functions, one where B is equal to 0 and one where B is not equal to 0. We'll make them easy. Let's go x squared plus 2x. Let's make it more than 2x maybe. X squared plus 5x minus 2. Okay, here is one quadratic function. The parabola is opening upward. If we look at the y-axis, does the y-axis split this parabola right in half? No, it doesn't. The parabola or the axis of symmetry is not the y-axis here. That's because we have a b term there. B is equal to 5. Okay. But what if we just got rid of the 5x? If we look at the graph of x squared minus 2. The graph of x squared minus 2 is split in half by the y-axis. That means that the y-axis is the axis of symmetry. And that only happens when b is equal to 0. I'm going to graph these two together now. So for the green function, that's shifted over to the left a little bit. The y-axis does not split the function in half. That happens when b is non-zero. So if you have a b term, the graph is not going to be symmetric with respect to the y-axis. But if there is no b term, if b equals 0, then the graph is symmetric with respect to the y-axis. Okay. Back to our book. So that's what we mean here. When b equals 0, the axis of symmetry is on the y-axis. We should also note, I have to go back to Desmos really quickly. Also note, when the axis of symmetry is the y-axis, the vertex is also on the y-axis. The vertex in this case is 0, -2. And if the axis of symmetry is not on the y-axis, then the vertex is not on the y-axis. That one's -2.5, -8.25. All right, so that's what B tells us about our graph. And then last part, which is my favorite and the easiest part. What does C tell us? If you look at this equation, f of x equals ax squared plus bx plus c. If x were equal to 0, we would just get c. But when x equals 0, that means that we're getting a point that's on the y-axis. That gives us our y-intercept. So the constant term c tells us what our y-intercept is. C is the y. Where's the thingy? Boom, y-intercept. So going through this one more time, and then we can jump into our problems. A tells us if our parabola opens upward or downward, a positive, so that's the x squared term. A positive x squared term opens upward, negative x squared term opens downward. And then think about where your vertex would be. If it opens upward, the vertex is at the bottom, so it's a minimum. If it opens downward, the vertex is at the top, so it's a maximum. If there is a b term, then that means that the parabola is not symmetric with respect to the y-axis. So their y-axis is not the axis of symmetry. If b does equal 0, so if there is no b term, then the y-axis is the axis of symmetry, and the vertex is on the y-axis in that case. And then last thing, the value of c tells us the y-intercept. All right. Now you may not believe this, but we actually haven't even started the problems yet. Problem number 1. We are asked to take the quadratic functions that are given and do not let the missing terms fool you. Without using a calculator, state whether or not b equals 0, then determine if the vertex is on the y-axis. Remember, if b equals 0, the vertex is on the y-axis. If b equals anything else, the vertex is not on the y-axis. So for this first function, f of x equals 2x squared minus 3x plus 5. B is equal to negative 3. That's not 0, so the vertex is not on the y-axis. That's it. That's all we have to do. For the next one, h of x equals 2x squared. Technically, that's plus 0x plus 0. So there is no x term there. It's not written, but it's implied that it's 0. So in this case, b would be equal to 0. And that means that, yes, the vertex in this case, for a 2x squared, the vertex is on the y-axis. All right, and then for the last one, g of x equals negative x squared plus 4x. Here, 4x is our b term. So it's a linear term. So b is equal to just the 4. We just want the number. B is equal to 4. That's not a 0. So we would say that the vertex is not on the y-axis. Again, if b is 0, your parabola is split in half by the y-axis and the vertex is on the y-axis. If it's not 0, then it's not. So only that middle function, h, has a vertex on the y-axis. It would actually be at 0, 0 at the origin. All right. Now that we have that down, remember, as always, you guys can jump in with any questions you might have. Problem 2 is worked out for us, but we're going to just look at this really quickly. We're going to be given a quadratic function. We want to identify the values of a, b, and c. So that's the coefficients of each term. And then from there, we want to determine, does our parabola open upward or downward? Is the vertex on the y-axis? And then what is the vertical or y-intercept? All right, like I said, problem 2 is done. Let's jump to one that we can do. Problem 3. Here we have f of x is equal to negative x squared plus 3x. So in this case, here's our function. In this case, a is equal to We have negative x squared, so a is equal to -1. And then plus 3x, b is equal to 3. And then there is no constant term, so c is equal to 0. All right, which direction does the parabola open? Since our a term is less than 0, this tells us that the parabola opens downward. So we're going to have a downward opening parabola. That's an ugly parabola, but you get the idea. Something that'll look like this. Okay. And then is the vertex on the y-axis? B is equal to 3, which is not 0. So B is not equal to 0. So the vertex is not on the y-axis. Okay, and then the last thing we're asked, what is the vertical intercept? C is equal to 0. So our vertical intercept, or y-intercept, is at 0, c. So that would be 0, 0 at the origin in this case. All right. Next, we're asked to complete the table and give a sketch of the function. We don't really have enough information to sketch the graph quite yet, but we can graph it and then show what the graph looks like and sketch it here and confirm whether or not all of these things are true. So let's go to Desmos and graph this function. It was -x squared plus 3x. Ta-da! All right. When we look at this function, we see that, yes, it is a downward opening parabola. Yes, it does have a y-intercept at 0, 0. And then also, no, the y-axis does not divide this parabola in half. Okay. On Desmos, we can kind of click on these dots and easily find the x-intercepts and the y-intercepts in the axis, in the vertex, but we're going to talk about how to find these things algebraically in just a second. If we look at our graph, we had 0, 0, and then 3, 0 were the x-intercepts. The vertex was about here, and then we had a downward opening parabola. So we would just want to try to make this as even as possible on both sides and draw our downward opening parabola. As you can see, I'm no artist, but that's a decent enough sketch. I should be able to see all of the important parts of the graph. And it should match up with what we have. Also, this was not asked on this part, but what would the axis of symmetry be? It would be the vertical line that goes through the vertex, which is this line. X equals 1/2. We'll talk about how to find that algebraically in just a second also. So in problem 4, we're asked to match each function with the graph. So we're given two functions, f of x equals x squared minus 3, and f of x equals x squared plus 2x minus 3. One of these graphs has b equal to, or functions has b equal to 0, and one has b equal to 2. And then based on that, we want to determine which graph it will match up with. You can look at which graph has an axis of symmetry at the y-axis. So which is which? When we look at the graphs, the axis of symmetry, which is x equals 0, is the y-axis for the graph on the right-hand side. However, on the left-hand side, the axis of symmetry is not on the y-axis. So what does that mean in terms of these graphs? Okay, in terms of the functions. For f of x equals x squared minus 3, b is equal to 0, which means that the vertex and the axis of symmetry are on the y-axis. And that would match with this graph. For x squared plus 2x minus 3, b is equal to -2, so the vertex is not on the y-axis. That would match with this graph. So big thing is, remember, if b is equal to 0, then we have a function that is perfectly symmetric with respect to the y-axis. Otherwise, our vertex is not on the y-axis, and we'll have to do a little bit more work to find it. All right, let's jump into problem 5, which is one more of these where we identify A, B, and C, determine if the parabola opens upward or downward, find the vertical intercept, and then sketch the graph after looking at the graph on Desmos. Here we have x squared, f of x equals x squared minus 2x plus 3. A in this case is 1, B is -2, and C is 3. Okay. Based on the fact that A is 1, does this parabola open up? Or which direction does this parabola open and why? This parabola opens upward. And that's because A is greater than 1. I'm sorry, A is greater than 0. It's equal to 1, so it's greater than 0. All right, and the last part, what is the vertical intercept as an ordered pair? C is equal to 0. I'm sorry, C is not. C is equal to 3. So the vertical intercept or the y-intercept would be the ordered pair 0, 3. All right, what do we know at this point? Now we know how to take a quadratic function. From the value of A, we can determine if our function opens upward or downward. From the value of C, we can find the y-intercept. And then from B, we can just know if our vertex is on a y-axis or not. All right, what if we want to actually find the vertex? We can do that also. We're going to define that in the next part. All right, so if we are given a quadratic function, how do we find the axis of symmetry and the vertex algebraically? Using this formula. The vertex is the lowest or highest point on a parabola. It gives you either a maximum or a minimum, depending on whether or not your parabola opens upward or downward. To find the input value of the vertex, or the x-coordinate of the vertex, we have this, a formula which we need to memorize. It's going to pop up a lot, okay? X equals -b over 2a. All right, x equals -b over 2a. All you need to know is b and a, plug it into this formula, boom, that tells you the x-coordinate of the vertex. Then how do you find the y-coordinate? You plug whatever x is back into the function, and that'll tell you what y is. So substitute this input into the function to determine the corresponding value. I'm just going to write that out a little bit more. Y is going to be equal to f of -b over 2a. So whatever -b over 2a is, you plug that into the function, and boom, that'll give you your y. Then you want to write your vertex as an ordered pair usually. Vertex is -b over 2a, comma, f of -b over 2a. Looks funky with the letters, but remember, we're going to know what a is and know what b is, so we'll be able to get numbers for these values. All right. Also, -b over 2a gives us the equation for the axis of symmetry. Remember, the axis of symmetry is just a vertical line that goes through the vertex. Well, the x-coordinate of the vertex is -b over 2a. So the axis of symmetry is x equals -b over 2a. So -b over 2a gives us two things. X equals that is the axis of symmetry, and then it also tells us the x-coordinate of the vertex. A 2-for-1 special. We like this formula. Number 7, given the quadratic function f of x equals 5x squared minus 20x plus 3, complete the table and generate the graph of the function and plot and label the vertex and the axis of symmetry on the graph. All right, let's do it. First, we want to identify A, B, and C. A equals 5 here. B is -20. C is 3. All right, that should be an easy part for us. From here, determine the coordinates of the vertex. This is where we get to use our new formula. The x-coordinate of the vertex is negative b over 2a. Negative b over 2a. What is that in this case? B is negative 20, so we get negative 20 over 2 times a is 5. 5. And then we simplify this. That would be negative gives us a positive 20 over 10, and 20 divided by 10 is 2. So the x-coordinate of the vertex is 2. All right. What about y? What's y? Y is going to be equal to f of 2. So plug 2 into the original function, see what you get. We get 5 times 2 squared minus 20 times 2 plus 3. That would be 20 minus 40 plus 3. Negative 20 plus 3 is negative 17. All right, now we want to put these two things together. X equals 2, y equals negative 17. We want to write our vertex as a point, an ordered pair. So the vertex is 2, negative 17. So use negative b over 2a to find x. Once you find that, plug it into the function to find y, and then write out your ordered pair. Also, the last part we've already done. Finding the axis of symmetry. Remember, that's the exact same as finding the x-coordinate of the vertex, except you want to keep the x equals part because you have to write it as the equation of a line. So it would be x equals negative b over 2a, which was negative 20 over 2 times 5, which you got from earlier is 2. We could just write out the equation. No, you don't have to do the work again. X equals 2 would be the axis of symmetry. All right. All right, now we want to put all of this information together and graph. We were asked for the y-intercept, we should have been. All right, so it says find the coordinates of each x-intercept using your graphing calculator, and then sketch the function, plot and label the vertex, axis of symmetry, both x and y intercepts, and the graph. Okay, oh, I'm sorry, on the graph. What have we gotten so far? Well, let's go to the graph of the function really quickly. It was 5x squared minus 20x. What was it, plus 3? All right, this is what the graph would look like. On Desmos, it's pretty easy to find the, confirm our vertex. It's 2, negative 17. That was correct. We also know that c is equal to 3, so the y-intercept should be 0, 3. That's there. For the x-intercepts, finding them algebraically is going to take a little bit of work. We won't be able to do that today. We'll learn that over the next couple of classes. But we can find them on the graph. Boom. The x-intercepts are not nice whole numbers, but that's okay. They're at 0.156 and 3.844. We just need to have an idea of where they are so we can plot them on the graph. All right, let's put all of this information together. So on our lovely graph here, let's start off by plotting the points we do know. 0, 3 for the y-intercept. And then for the x-intercepts, there's one at like 3.8 and one at 0.1 something, really close to 0. Okay, and then we know the vertex. The vertex is negative 17 or 2, negative 17. And we know that our parabola is opening upward. So we're going to draw an upward opening parabola that goes through all of these points. All right, it's going to decrease, then increase, boom. And I should indicate that it keeps increasing on this side too. Boom. Ta-da, that's what our parabola looks like. We can label the vertex. Oh, we have to label the vertex, -2, 17. We're also asked to draw the axis of symmetry and label that. The axis of symmetry, we usually draw with a dashed line. So it's this dashed line, x equals 2. On to problem number 8. Given the quadratic function g of x equals -x squared minus 6x plus 1, complete the following table. All right, what's a, b, and c in this case? We have -x squared. So a equals -1 minus 6x, b equals -6 plus 1, c equals 1. Determine the coordinates of the vertex. X is going to be equal to -b over 2a. That's -6 over 2 times -1. So that's 6 over -2, which gives us a -3 for the x coordinate. And the y coordinate would be, oh, it's g. G of -3, which is -3 squared minus 6 times -3 plus 1. Oh, we have to simplify that. Okay. So that gives us -9 plus 18 plus 1, which would be 10. Putting those two pieces together, our vertex is -3, 10. And is the vertex on the x-axis? I'm sorry, on the vertical axis, which is the y-axis? Y? No, because b is not equal to 0. If b was equal to 0, the vertex would be on the x-axis, but it's not. Also, I mean, we can just look at that point. I keep saying the x-axis. I mean the vertical axis, which is the y-axis. But also, if we look at the point, -3, 10, that's clearly not on the y-axis. So no, you can use either of those explanations. Look at the point, it's not on the y-axis, or b is not equal to 0. All right, the axis of symmetry. We already did the work for it. We saw that the x coordinate was -3, so x equals -3 is the axis of symmetry. That is the vertical line that will split our parabola in half. All right, we weren't asked for the y-intercept explicitly, but we can find it. We know c is equal to 1, so the y-intercept is 0, 1. All right, let's plot a couple things. We know that 0, 1 is a point on the graph. We know that -3, 10, which is all the way up here, is a point on the graph. A is -1, so this is going to be a downward opening parabola. And then we just need to figure out some information about the x-intercepts. I'm going to show them to you really quickly on Desmos. -x squared minus 6x plus 1. The vertex is -3, 10. Yay, we got that right. Y-intercept is 0, 1. Yes, we got that right. The x-intercepts are at about -6.2 and 0.16. So -6.2 and 0.16. All right, let's plot those points. So we'll have an x-intercept probably about here and about here. Let's put all of this stuff together. Downward opening parabola. Vertex is up here at the top. Has to go through these points. Cool. And then keeps decreasing. And it goes the other way as well. And keeps decreasing. This is what the shape of our parabola should look like. Media example number 9. We have the quadratic function x squared minus 2x plus 3. A in this case is 1, B is -2, C is 3. Okay. The coordinates of the vertex would be x equals -b over 2a. So -2 over 2 times 1. That's 2 over 2, which is 1. X coordinate of the vertex is 1. For the y coordinate, y would be equal to f of 1, which is 1 squared minus 2 times 1 plus 3. 1 minus 2 plus 3 is 2. The vertex here is 1, 2. All right, what is the x-axis of symmetry? X was equal to 1, so the axis of symmetry is x equals 1. And then C was equal to 3, so the y-intercept is 0, 3. We can plot the points that we know. Oh, this also, is it upward opening or downward opening? It opens upward. All right, so we can plot 0, 3. That's the y-intercept. We can plot 1, 2. That's the vertex. Now, we can go and graph this and then try to find an x-intercept, but let's think about this. If our vertex is above the x-axis and our graph is going to open upward, whatever our picture is, it's going to look something like this. And it's never going to cross the x-axis. So this is an example where there are no x-intercepts. That is possible. All right, last thing we need to know for our basic introduction to quadratic functions is how do we find the range of a quadratic function? And that's going to depend on your vertex, particularly the y-coordinate of your vertex. So for the domain and range, domain is easy. Nobody should ever get a domain problem wrong when it comes to a quadratic function. The domain of a quadratic function is all real numbers, all the time, every time, no matter what. This does not change. The domain is all real numbers. For the range, we do have to do a little bit of thinking. For the range, we have two different cases. When our parabola opens up, the range is all y values that are greater than the y-coordinate of the vertex. What on earth does that mean? Okay, if we have an upward opening parabola, the vertex is a minimum. The vertex is the smallest point on the graph. So let's say this point is, I don't know, I'll call it C, D. Okay, then D is the smallest value of y that this function can ever attain. The y values just keep getting bigger and bigger and bigger than D. So we would say that the range is y is greater than or equal to D. Whatever D is, the y-coordinate of the vertex, all of the y values are greater than or equal to that. All right, what if our parabola opens downward? If we have a parabola that opens downward, we get y is less than or equal to the x-coordinate of the vertex. If we draw a picture for that, a downward opening parabola would look like this. The vertex would be here. It would be a maximum point. So if this point is C, D, D is the highest possible value of y that we can get. So the range would be y is less than or equal to D. All right, and then for the domain of a quadratic function is all real numbers every single time. For these problems, we're asked to determine the domain and range of f of x, sketch the graph, label the vertex. We're asked to find the vertex graphically. We just did a problem like that where we practiced finding it on a graphing calculator. So I'll just do this one algebraically again, and then we'll find the domain and range. Actually, let's just do the domain now because it's so easy. The domain is all real numbers. It's a quadratic function. The domain is always going to be all real numbers. We can plug in anything for x. For the range, we need to know the vertex first to figure out the range. In this case, x is going to be equal to -8 divided by 2 times 1. So that would be 8 over 2, which is 4. Then y equals f of 4, which is 4 squared minus 8 times 4 plus 2. That's 16 minus 32 plus 2, which would be -14. So the vertex in this case is 4, -14. Where is that? 4, we need to make more spaces down here. 11, 12, 13, 14. The vertex would be off the grid, way down here. And then this is an upward opening parabola. We see the y-intercept is at 2. So we're going to have a parabola that opens upward. Hold on. Here we go. That's better. Opens upward. It'll look something like this. We see that vertex is a minimum point. That's a minimum. And again, the coordinates here are 4, -14. So the smallest possible output we can get is -14 because the graph just keeps going up after that. The range would then be y is greater than or equal to -14. For number 12, we have the domain is, the domain is all real numbers, so we can type that in. Our function, though, is f of x equals -x squared minus 6x plus 1. We've done this one already. Again, all real numbers for the domain. For the vertex, x is equal to -6 over 2 times -1. We did this one earlier. This gives us 6 over -2, which is 3, or -3. Y would be -3 squared minus 6 times -3 plus 1, which is 10. So -3, 10. -3, 10 is here. Our x-intercepts were about here. Our y-intercept is 1. And we have a downward opening parabola. So the graph is going to look something like this. All right. Then that brings us to the question of the range. In this case, 10 is the highest possible y value we can get. That means our y values are going to be less than or equal to 10. That's the range. Problem number 13, similar type of problem. We have f of x equals 2x squared minus 6. So b is equal to 0 in this case. That means that our vertex is going to be on the y-axis. This one's actually not too bad. The domain in this, we aren't even asked to find the vertex, but we're going to have to find it. The domain in this case is still all real numbers. For the vertex, if we're finding it algebraically, x would be equal to -0 over 2 times -2. That's just going to be equal to 0. So the x coordinate is 0. Y would then be equal to f of 0, which is -2 times 0 squared minus 6, or -6. The vertex is the ordered pair 0, -6, which is here. This parabola is going to open downward. So there are no x-intercepts. The y-intercept is the same as the vertex. And if we have a downward opening parabola, it's going to be kind of narrow. The graph will end up looking something like this. And that y value of -6 is a maximum. -6 is the highest possible y value we end up getting for this graph, because our graph keeps going down, so the y values are going to be smaller and smaller. So for the range, we have y is less than or equal to -6. All right, that's it. What we should be able to do, or what we need to take from this section. If you're given a quadratic function, f of x equals ax squared plus bx plus c, you should be able to find the y-intercept, find the vertex, find the axis of symmetry. You can do all of these things algebraically, and then find the x-intercepts graphically. And then put all of that information together to sketch a graph. And, oops, I missed one thing. Find the domain and range. That's everything that we did today.